Hi, this is Nathan Tintle. In this Learning Goal video, we're going to talk about how to anticipate the impact of changing from a one-sided to two-sided test. We'll use the Competent Faces data to discuss this learning goal. We've talked before about how the alternative hypothesis determines how you compute as extreme when you compute the p-value. For a one-sided test, this is where the alternative hypothesis is either greater than or less than, you look in either the upper tail or lower tail of the null distribution to compute the p-value. If you use a two-sided test, this is where your alternative hypothesis says not equal to. You look in both tails for the p-value. Let's look at an example. Here's the Competent Faces data. Remember that in 23 out of 32 elections, the Competent Face method correctly predicted the outcome of the election. In the graph on the left, we've done the one-sided alternative hypothesis test. That is, we've tested to see if the Competent Face method yields a probability of success greater than 50%. Here the p-value is approximately 0.01. We look at 0.72 and greater. 0.72 is the observed proportion of times the Competent Face method correctly predicts the outcome, and we compute as extreme as in the greater than direction because that's the alternative hypothesis. In the graph on the right, we show how the two-sided p-value is computed. Here, this is for an alternative hypothesis of not equal to. We're saying for all the alternative hypothesis that the long-run probability the Competent Face method correctly predicts the outcome of the election is not equal to 50%. In this case, the p-value is computed by looking in both the upper tail, greater than 0.72, as well as in the lower tail, in this case less than 0.28, to find the p-value. You take both tails and add them together, so the p-value approximately doubles to 0.02. On symmetric distributions, as we often have, like the distribution here, when you go to find the lower tail, you simply go the same distance to the left as you did to the right. So the center of this distribution is 0.5, so we went up 0.22 to find 0.72. We also then go 0.22 to the left down to 0.28. Don't worry about that so much. The applet will compute that for you. So, the p-value approximately doubles when moving from one-sided to two-sided tests. That will always be the case, which means that there will always be less strong evidence with a two-sided test. Why does this make intuitive sense? Well, a two-sided test is more objective. Remember, the researchers are assuming less ahead of time. In the case of the Competent Face data, this means the researchers are assuming less about the direction of the effect. So we're not sure if the Competent Face method will do better than 50% or worse than 50%. Because you're assuming less ahead of time, it's harder to overturn your null hypothesis. There's less assumptions ahead of time, so we need more data to end up with the same strength of evidence. A couple of cautions. Should you always use one-sided tests because they'll give you stronger evidence? Well, actually, in practice, two-sided tests are used more regularly because they make less assumptions. They're more objective. Researchers try to be as objective as possible, and so two-sided tests are generally more widely used. One-sided tests are absolutely great if the researchers are correct about the direction of the effect. But of course, if they're wrong, it's disastrous because, for example, if the researchers thought that the Competent Face method would do better, when in fact it does worse, your alternative hypothesis only looking for better than won't allow you to find that it might actually be an effect in the opposite direction. Some students think then that they should just pick which side to look at after seeing the data. In other words, do a one-sided test in the direction of the effect that you actually see. This is pretty much like cheating. You're using the data to set hypotheses and then testing the hypotheses using that same data. You should always set your hypotheses before you do the study, before you collect the data, and based on prior research and prior understanding of the research area.